So in this video, we're going to be talking about a barycenter. So a barycenter is basically where two different objects rotating around each other have a center of mass. This point where there's the center of mass means that on one side, this entire object or planet has the exact same mass as the other object on the other side. This center of mass is known as the barycenter. So we're going to be applying the barycenter to astronomy, mainly about planets. So a common misconception is that when we look at planets and our sun, we say that our planets rotate around the sun. When in reality, that's not true. Our planets rotate the barycenter. The barycenter is the center of mass between two objects orbiting around each other. So, for example, let's take the Earth and the Sun. The Earth and the Sun have a certain point known as the barycenter, where the Earth is able to freely rotate around the Sun without it colliding into the Sun or losing gravity from that Sun. Now, although we say it rotates around the barycenter, for most of these planets, the barycenter is located inside the Sun, except for Jupiter. If you look at Jupiter, the barycenter is just outside of the Sun's surface. So because it's just outside, Jupiter is the only planet where we can actually say Jupiter orbits around the barycenter. But although all the other planets also rotate around the barycenter, the thing is that since the barycenter is inside the Sun, we can technically say for all the planets except for Jupiter, they rotate around the Sun. So now we're going to be seeing the barycenter through a simple demo. Let's take these two. So these two ping pong balls have the exact same mass. So because they have the exact same mass, hold up, let me get it. All right, that's good. All right, so since these two ping pong balls, as we can see, have the exact same mass, the barycenter will be at the center because this mass over here is equivalent to this mass over here. And because of that, if two of the same celestial objects in our solar system have the exact same mass and if they're rotating each other, the barycenter will be located at the exact middle of the entire thing, okay? So now let's get even more complicated. Let's take an object that has more mass, like our sun, to an object that has less mass. If we were to put this at the center, it doesn't work. So in this situation, this would be colliding into this because this is heavier. But if I were to make this very close, oh no, wait, now this one has too much weight, so this will be drifting away from this bigger celestial body. So the barycenter is the perfect point where a planet will not drift away or collide into another celestial object. So through that, we have to find the perfect place where it is able to easily balance. And when we look at the barycenter of the other planets, typically their barycenter is located in the Sun because their mass isn't as much or like bigger compared to the Sun. Only Jupiter's mass, since it's the biggest and since it has a lot of mass, the barycenter is just outside of the Sun. So, all right. So let's say this smaller planet is Earth and this bigger planet or this bigger ping pong ball would be considered the Sun. So now they're able to maintain a free orbit around each other without colliding or getting or the gravity not being strong enough to hold them together. So that is how the planets actually rotate. They don't rotate around the Sun, they rotate around this certain point known as the barycenter. So if we were to take the Earth, for example, since the Earth does not have nearly as much mass compared to Jupiter, the barycenter is located inside the Sun. So since the barycenter is located inside the Sun, the sum of Earth's mass plus this distance plus a little bit of the sum of Sun's mass is equal to the completely other part of the Sun's mass. So it's kind of like algebra if you truly think about it. This part X and this part over here would be considered Y. So we have this thing over here, which we'll say is the original equation. We have one variable over here and one variable over here. These two variables, let's just say A. This variable A is A equals A, so we know that obviously. So since A equals A, we need to get this one over here to be able to equal A. So the length is obviously the same. So what we have to do is we have to manipulate the variables so that we're able to get this mass over here and this mass over here proportional to the mass of A. So we could say the mass of X is equivalent to the mass of A, and this mass of Y is equivalent to the mass of A over here. And so with that, we're creating basically a proportional relationship from two different perspectives, and using those perspectives, we're able to differentiate between the barycenters over here. Yeah. And by differentiating from the barycenters, we're able to see where the center of mass is, and we're also able to predict what happens if, let's say for example, this variable A, like something happens to variable A, like one of these ping pong balls like gets bigger or smaller, then we're able to estimate that amount. Also, using the barycenter, from looking at the other stars around us, like you're looking at their mass, we're able to create theories or estimate where other planets could potentially be. And looking at that, we could delve into further research as to where like the habitable zone or the Goldilocks zone is, where humans can survive in those temperatures. So using that, the barycenter is very important. So another example is the Earth-Moon system. Just like the sun, the moon also rotates around the Earth, but that also be kind of incorrect since the moon actually rotates around the Earth's barycenter. So since it rotates around the Earth's barycenter, the barycenter is actually located inside the Earth because the moon does not have as much mass compared to Earth. And because it's not like this kind of situation, it's more like this kind of situation. So what happens is we have to take the mass of the moon, a little mass of the Earth, and this entire distance, this entire part, let's say X, is equal to this entire part, which is Y. So through that, we can make another proportional relationship with other kinds of celestial objects outside of that. So in conclusion, barycenter is nothing but the center of mass for two different celestial objects rotating around each other in an orbit.